Okay, so today we are going to start looking at this idea of chance, okay? Now, chance and probability are kind of two things that go together, okay? So at the moment, or initially, we're going to start looking at the idea of chance as just simply a qualitative measure. In other words, can we simply take some events, take some things, and order them in a qualitative way, in other words, using words, okay? So I've put 5 words on the screen, okay? So I put impossible, unlikely, even chance, likely, and certain. Now, all I want you to do is take these kind of events in the box, okay? So there's 9 events in the box, so it will rain tomorrow, winning the lottery, etc., okay? And can I just ask you to put these events along this number line, okay? So there's 5 positions that they can lie in, okay? Can I just ask you to think about it for maybe 30 seconds and just think, where do these 9 events lie along this number line? Hello.
Is this the sheet you were talking about?
Yeah, page 90, question 99 we're going to start at in a minute. Okay, so I've given you 30 seconds to have a think through these things, okay? So where along this number line, from impossible to certain, are the chances it will rain tomorrow?
Even chance.
I'd say there's an even chance, like the weather is fairly unsettled at the moment, like we just had a storm over the weekend. I would say there's an even chance that it could rain tomorrow, we're not sure, okay?
Windy.
Yeah, exactly. So actually, I would probably push it slightly more than even chance, slightly towards likely. Yeah? Would you be happy with that? Okay, what are the chances of winning the lottery?
Unlikely.
Yeah, pretty unlikely, verging towards impossible. They're really, really small chance. Yeah, good. What's the probability that you find someone who likes ice cream?
Very likely.
Yeah, I'd say very likely, verging on certain almost. Like there's enough people, there's about 200 people at the college. You're probably going to be certainly find somebody who likes ice cream. Okay. Meeting someone with tattoos.
Likely.
Yeah, likely. Does anybody here have tattoos? No? Okay, fine. Yeah, but I would say it's pretty likely. Okay. What are the chances of waking up early tomorrow? Certain, unlikely, yeah, impossible. Depends who you are, I guess. What's the probability that we're going to pass maths? Okay, I'm not going to get you to answer that. What's the probability of being struck by lightning?
Unlikely.
Yeah, I'd say pretty unlikely, verging on impossible. Yeah, it's pretty unlikely. What's the probability of flipping a head on a coin?
Even chance.
Even chance, 50-50, right? What's the probability that tomorrow will be Saturday? It's impossible. Tomorrow's Tuesday. Last time I checked, today's Monday. Oh, I've got a full week left to go. Never mind. Okay, so does that make sense? So one way that we can think about chance is in a qualitative way. In other words, using words, okay? Now, this is okay, and it's enough to kind of get a feel for what's happening, but actually it's a lot better to do it in a quantitative way. So what do I mean by quantitative? What does it sound like? Yeah, numbers. So qualitative is using text, like words. Quantitative is using numbers, okay? So one way that I can really easily do that is by thinking about this, okay? So there's, again, 9 words on the screen. Can you think for a couple of minutes, maybe discuss it in your pairs or in your tables? What do these words mean? Okay, so you've got fair, you've got bias, you've got random, you've got an event, sample space, outcome. What do these words mean to you? Just out of interest, who in here does statistics? No one. Okay.
I hate statistics.
You hate statistics?
Yeah, it's so hard.
Depends how it's introduced, I guess.
It's like the equations and rules.
Okay, so what do we reckon? What does the word fair mean?
Even chance? Oh, no.
I mean, actually, these first two words go together. So you've got fair and you've got biased. What do they mean? What's the difference between the two?
Fair is like, you don't know what the outcome will be.
Right.
Like, there's a fair chance of getting heads, either heads or tails.
Okay, so stick with that example then. So flipping a coin, okay, you might say you flip a fair coin or you flip a biased coin. What's the difference between the two?
A biased coin will have a specific side it will go to. Certain.
Right, okay. So, I mean, it could, so say for example, it was biased towards heads. It means that there is more chance that that coin will land on heads than it will tails. But it could still land on tails, right? Yeah, it's just more likely to land on heads. So what's the difference between fair and biased then? Absolutely. So if we say that something is fair, it means that all of the outcomes, and outcome is a word on there, so we'll discuss that in a minute, but it means all of the outcomes are equally likely. Okay? So as another example, you could roll a fair dice. Okay? Now, if I say it's a fair dice, it means that there's an equal chance of it landing on each of the 6 sides. Does that make sense? Yeah? Whereas biased means it's more likely to land on one than the other. Okay? Good. What does random mean? York, what do you reckon random means? Yeah, what does it mean? What's that?
I choose something, I choose the other.
Okay, so there's not really any kind of logic behind it? Maybe? Yeah, okay. Anybody got any other suggestions?
Random means anyone, like, anything can happen. Like, it's not specific. Well,
Can I ask you, okay, so this is an interesting idea, okay. On the board, what we're going to do is write down a random sequence, okay. We're going to write down a random sequence. So let's choose, okay, you can choose any number from 1 to 10. Any number from 1 to 10, including 1 and 10, right? Actually, no, let's do it 1 to 9 because it might be slightly easier. So, can we go around the room? And what I want you to do is produce a random sequence for me, okay? So we'll just go around the room. So there's 1, 2, 3, 4, 5, 6 of us and 7 of us. So there should be a random sequence then which we produce, okay? So I'm going to start you off. I'm going to start off with 3. Archimed, give me a number between 1 and 9. 7. Okay. Batacan, how many? 6. Okay. York? How many?
it's under 10.
A random number between 1 and 9, you came up with 13. Okay. 9, okay. Yi? 5. 8. Megan? Just a random number between 1 and 9. 3? Okay. So this here would be a random sequence. Or would it? Okay, so let's have a look. Let's have a look at this. Why do you think this is random?
Because it's not in order. Or
Okay, so there's no order to it, absolutely. Like we start with 3, then we jump up to 7, then we jump back down to 6, then up to 9, then down to 5, etc. Good. What else doesn't make it random, do you think?
doesn't or doesn't?
Doesn't.
Doesn't make it random.
Sorry, it does make it random.
Oh, okay.
Sorry, yeah.
There's different numbers.
Yeah, I mean, apart from the 3s, but yeah, I mean, they're mostly different numbers. Like we've got a good spread across all of those 10, over those 9 digits which we could have used. Any other suggestions? What else makes this random, do you think? Okay, so no sequence, no kind of pattern there, right? So the difference between 3 and 7 is 4. Difference between 7 and 6 is 1. Difference between 6 and 9 is 3. Difference between 9 and 5 is 4. So there's no kind of pattern between the terms that we can see, okay? That's an interesting idea. So what about if I wrote this sequence down instead? Can you tell me whether this would be random? So we need 7 digits. Let's go this. Would this be random?
The number ones?
Yep, so the one in red. Would this be random?
No, not.
Why not?
Because it's the same numbers. There's no, like, it's just...
So everything that we just came up with which said that this sequence was random, so in other words, because there was no kind of order, they weren't in order, there was no kind of pattern between the terms, we're mostly using different numbers, this kind of breaks all of those things. But what if I told you this was just as random as this, okay? All random means, because it depends on the context, okay? It's a bit like people start to get a bit uneasy when you're flipping a coin, okay? And if it starts to come up with like 10 heads in a row, okay? The chances of you getting 10 heads in a row are pretty unlikely, but there is still a chance of it happening. It could happen just purely by chance. Is that okay? So just because you start to see this going on, you need to think about the bigger picture. Like eventually, if you start getting like 1,000 ones or 1,000,000 ones, they would start to think, this isn't quite random, but it still could be. It still could be, okay? So what random literally means is quite hard to define. It usually means something which is devoid of any kind of pattern, okay? Now, just because this starts off as a load of ones, it doesn't necessarily mean it's not random. An example, do any of you in here use Spotify? Yeah, so listening to music on Spotify, maybe listening to music on your phone, and maybe you click shuffle on your phone, it kind of shuffles through the music. Now actually, people, like when I first started listening to music, and this is kind of showing my age, when the MP3 players used to first come out, like people used to get really annoyed because they press shuffle and then it was the same song playing over and over again, like it might play 2 or 3 times. People say, this isn't random, like it's broken. But actually, that is just as random as playing a different song every single time, okay? And in actual fact, interestingly, things like Spotify and things like music players now, when you press shuffle, they actually have built into their algorithm a sort of a command which makes sure that you don't play 2 successive songs in a row. So actually a shuffle on a music app is not truly random, because if it was, they wouldn't have that thing built in. Okay? So just bear in mind that randomness just means it's devoid of any pattern, but it depends really what the pattern is and what it's talking about. Okay, okay, good. What about event? What about event? What do we think that means?
Sorry?
What does event, the next word in the list, mean? What does that mean?
Event.
Yeah.
There's no other word for it.
It's something which can happen, right? So it's something which can happen. For example, if you flip a coin, let's stick with that because we've been using it as an example up until now, an event could be getting 3 heads in a row. Does that make sense? Yeah? So events typically are more kind of broad than just an outcome. What's an outcome?
The result?
Yeah, it's the result of an experiment, okay? So for example, you flip the coin once and you get a heads, that would be an outcome. An event would be like getting 3 heads in a row. So you're putting lots of outcomes together. Does that make sense? Yep. We missed one. What about sample space?
It can be an experiment.
Yes.
Experiment.
Yeah, so keep with that. So it could be an experiment, for example, rolling a dice, or going around the college and sort of asking everybody, or maybe flipping a coin. So what's the sample space?
There's another word for it.
It's everything that could possibly happen. So it's all of the events that could possibly happen, right? So for example, when you flip a coin, what would the sample space be if you flip a coin once?
Either heads or tails.
Heads or tails. There's 2 things that could happen, okay? Heads or tails, that would be the sample space. I guess you could also get an edge coin, yeah, so where it actually lands on the edge, but that is pretty unlikely, okay? So if you wanted to consider the true sample space of flipping a coin, it should either be heads or tails, okay? Okay, what about dependent versus independent?
All this is linked to the probability?
Absolutely. These are all words that could come up in probability, so it's important you understand them. What's the difference between dependent and independent?
Dependent is like when something is conditioned upon something else happening.
Good. So dependent literally means the chance of one thing happening is affected by something else already having happened. Okay? That make sense? Yeah? So what's independent mean?
It's the opposite of that.
Yeah, so if you have 2 events, if they're independent, it means they're not related to each other. So for example, Megan opening her sweets and York falling asleep are independent events. Yeah? Because one thing happening is not going to affect the other. Like York's going to fall asleep no matter what, and Megan's going to carry on opening her sweets no matter what. Okay. What about complement?
I do not know that.
Now you've got to be careful of the spelling here, Because usually complement is spelt with an E, so C-O-M-P-L-I-M-E-N-T, okay? And that is like, oh, your hair looks nice, right? Whereas complement with an E, what does that mean?
Complement. Like something going alongside?
Absolutely right, it goes together, okay? Two things that go together. So for example, you might be eating a really nice meal and the waiter might come across and say, would you like this wine? Because it complements the meal. That's what they're talking about here, okay? Because it goes with it, right? So in probability, a complement is usually the other thing that can happen, okay? So for example, think about the sample space of flipping a coin, heads or tails, right? Heads would be one outcome. What would the complement event be? What would the complement outcome be?
The tail.
The tails, right? Because they go together, okay? Likewise, if you roll a 6 on a dice, what would the complement outcome be?
Sorry, if we roll what?
If you roll a 6 on a dice, what would the complement event be?
What do you mean 6 on that? Oh, complement event. It will be 4 other side, 5 other side.
Exactly, 1, 2, 3, 4, 5, 6, and not rolling a 6. Does that make sense?